Welcome grade 9 to today's maths class. Today we'll be looking at slope-intercept form. Alright, so remember, mathematics is fun. Let's get right into it. Slope-intercept form. The slope-intercept form is probably the most frequently used way to express equation of a line. In general, the slope-intercept form assumes the formula y equal mx plus c, and I know that if not all, most of you may have seen this before. Alright, so procedure. To be able to use slope-intercept form, all that you need to be able to do is find the slope of a line, find the y-intercept of a line. So again, 1, find the slope of a line, 2, find the y-intercept of a line. Alright, very simple. Step 1, find the slope. So if you remember, y equal mx plus c, the m means the slope or gradient. Alright, and to find m, there are two methods. You could use rise over run or the formula method. Alright, so as you can see with this formula, they're actually indicating points. So x1, y1 is the coordinates of the first point in the line. x2, y2 are the coordinates of second point in the line. Alright, so step 2, find the y-intercept. If you remember, y equal mx plus c, the c is the y-intercept. So the y-coordinate of a point where a line intersects the y-axis, that is the y-intercept. So alright, so the y-coordinate of a point where a line intersects the y-axis. Simple. So fun fact, as you have realized, we have been using y equal mx plus c. That is commonly used in Britain, but there's also another way you could write it, which is a commonly used way in the America, where you have y equal mx plus b. Alright, but nevertheless, c and b means the same thing. They are both y-intercept. Alright, so let's look at the graph. So on the graph here, we have m, which is a slope, which is a line, and b, the y-intercept, right here. Alright, so if you remember from the meaning of y-intercept, the y-coordinate of a point where a line intersects the y-axis. Alright, let's look at a video. So in this video, we are here to find out the slope when given a graph. Alright, so let's look at it. So this video don't have any sound, I'll be narrating, so bear with me. So there are different types of slope. There are 4 types: positive, negative, 0, and undefined. So alright, slope is sometimes referred to as the rate of change between 2 points. Slope is a measure of steepness. Slope is rise over run. Alright, if given the graph of a line, find the slope by using the triangle method to find the rise over run. So alright, so we're given a line, and using the triangle method, we'll be finding rise over run. So when using this method, pick a point where the graph crosses nicely. Next, pick a point to the right of the first point. Now draw in your triangle, beginning with your first point, going up and to the right for a positive slope, or down and to the right for a negative slope. Alright, so here we have our line and we have our triangle. Alright, so as you can see, rise over run. So as we rise, if you count carefully, it's actually 4. And when you go across, it's actually 5. So you rise 4, run 5. And to write that as a fraction, you have 4/5. So next, you look to this graph. Alright, so remember, when you write it as a fraction, it is also the meaning of the gradient or slope. Alright, so rise over run. Here you realize that from your different types of slope, you realize that this slope is slanted this way, which indicates it's a negative slope. So that's why when you count your rise and your run, you have -2 instead. And then when you count carefully your run, you have 3. So hence the gradient -2/3. So if you were to choose a different point, keep the same point and use this point, you will still have the negative, which is -4, and when you count across, you have 6. So then you have a new gradient of -4/6, but it can still be reduced to -2/3. So it shows that even when you choose different points on a line, you will still get back the same gradient. Alright, simply enough. So let's look at a different video to get a different perspective. In this video, instead of given a graph of a line, we're given points. Alright, so here's our points: -6, 3, 4, -3. Alright, so we're going to draw those points. So you have -6 on 3, x-axis -6, y-axis 3, +3, and then for -3, x-axis +4, y-axis -3, and you draw your line, straight line. Alright, so remember in the method that we just used in the previous video, rise over run, we could use that here also. Alright, to find the gradient. So now if you count carefully, you realize that your rise is actually 1, 2, 3, 4, 5, 6. Alright, but remember that this is a negative slope, so that would be a -6. Alright, and then when you go to do your run, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you have 10. Alright, so actually you have -6 for your rise, and then you will have 10 for your run. Alright, so remember your types of lines. This is a negative slope, so you have to ensure your rise is negative. Alright, so now you write that as how we write the gradient as a fraction, -6/10, which is rise over run. So we could simplify that by dividing with 2 to get -3/5, and it can't be simplified anymore, so that is the gradient. Alright, so we basically is finished here. But if you were to try a different method now, which is the coordinate method using the formula, here we have y2 take away y1 and x2 take away x1. But first we need to identify these points. Alright, so remember that this is our first point, this is our second point. So -6 would be our x1, 3 would be our y1. So with our second point now, we have 4 as our x2, -3 as our y2. Alright, very simple. So we'll just substitute into the formula. Alright, very simple. So we have -3 for y2, -3 again for y1. Please notice this is a subtract, and when you put the 3 there, you get this. Alright, but then you put in your x2, 4, take away x1, gives you -6 here. But remember, this is different. You have your subtract and plus and -6. So that's how you change this to a plus, because 2 negatives gives you a plus. Alright, when you work it out, you get -6 over 10, and when you simplify, you get -3 over 5. So you get back the same answer as you get in a rise and run. So it's very simple. Alright, class? So let's move on. So activity 1, find the gradient of the following line segments. Here we have A, B, C, and D, and all of them are triangles. If you notice, you could use your triangle method to find the gradient, or you could use rise and run. Alright, very simple. So to give you a hint, just like with lines, this would be your slope, and then this you use as your rise and run. Alright, very simple. Please note that for this triangle, the units aren't the same, so you need to change the units. Alright, you'll have to be the same units before you can work out your rise over run. Alright, very simple. So next, draw a line given the gradient and the point. So if you remember the last videos, we were given a line for the first video, and then for the second video we were given points. But here we are given a line and a point, and you are to draw. Sorry, I made a mistake. So in fact, here we are given gradient and a point, and we are supposed to draw a line. So with the first video that we did, we were given the graph of a line to find the gradient, and then the second video we were given points to find the gradient. But here we are given a gradient and 1 point to find a line. Alright, so here are the steps. So step 1, plot the given point. Secondly, move horizontally and vertically according to the instructions given by the gradient, and mark another point onto the Cartesian plane. Third, finally, draw a line through and beyond these 2 plotted points. Alright, so continuing. So let us follow through these steps and draw a line passing through the point 1, -2 with a gradient of 3. So step 1, plot the point 1, -2. Step 2, look at the gradient to determine the instructions it is providing. So gradient, as you remember, rise over run, or change in height, change in horizontal distance. We know that the gradient for this question is 3, and we express this as 3 over 1. Alright, so any gradient that is not a fraction and it is given a whole number, you automatically change it to a fraction by putting 1 underneath it. So 3 over 1. So that's the gradient. So we take a particular note that the gradient in this case is positive. This means that from our plotted point 1, -2, we move 1 unit horizontally to the right and 3 units vertically upwards. This is the position of the second point. So alright, you draw your point, which is step 1, -2. So we have 1 on the x-axis positive, -2 on the y-axis, they meet here. This is your first point. So after you get your gradient, which is 3 over 1, you realize that you move 1 unit horizontally and 3 units upwards, which leads you to your second point. Alright, that second point now is +2, 1. Alright, so very simple. So after you get your second point, you draw a straight line through it, and that's how you draw a line given a gradient and a point. Alright, very simple. So here's an activity. Draw a line with a gradient of 2 passing through 3, 1. Number 2, draw a line with a gradient of 2/3 passing through the point -1, -2. Very simple. So if needs be, just refreshing yourself by looking back at the videos and also my example to do this. However, I don't think you will get too much trouble doing this, because after explaining it so thoroughly, it should be quick maths for you. Alright, so if you have any question, don't hesitate to ask. Leave a comment. I'll get back to you in a timely manner. And just so you know, I'm human just like you, so as I said, I'll get back to you in a timely manner. Alright, so please remember to like, share, subscribe. Please, when I see your likes and your subscriptions, it motivates me to make even more videos and better, improved ones also. Alright, so hope I'll see you again.